Write the expression that results from the following series of steps. Start with n and double it. Right, so it's algebra, but remember, what works with number works with algebra. So let's just imagine for a second that we started with 5 and then we doubled it. Doubled means times 2, so we'd have to do 2 times 5. But we haven't started with 5, we've started with n. So instead of 5, wherever the 5 was, I'm now going to put an n. So it's 2 times n. So started with n and I've doubled it is 2 lots of n, 2 times n. In algebra we don't tend to use the times symbol because it looks like x. So it's just 2n. Start with y and subtract 4. Again, what if I started with 5? 5, subtract 4, 5, take away 4. That's what it would look like. But I haven't started with 5, I've started with y. So where the 5 was, I'm going to change it to be y. So it's y, take away 4. Start with y, subtract 4. I've started with y, take away 4. Write the expression that results from the following series of steps. Start with 10 and subtract x from it. So if I was doing start with 10 and subtract 5, I would have to do 10 take away 5. So that's the number version. We haven't started with 5. We haven't subtracted 5, sorry. We've subtracted x. Start with 10, take away x. So you can see that all that's changed was it was 5 in our number version. We've now changed it to x in our algebra version. Start with 10, subtract x. Start with p and triple it. Again, if I started with 5, now I've been starting with 5 a lot, you could start with any number just to try it out. So if I started with 5, tripling it means I'm timesing by 3. 3 times 5, or 3 lots of 5. We're not starting with 5, we're starting with p, so the 5 becomes p, and we're tripling it, so it's timesing by 3. 3 times p, remember, we don't use the times in algebra because it looks like x. So we miss it out, it's just going to be 3p. Start with p and multiply by itself 3 times. Let's look at what we would do if that was starting with 5. So remember what works in number works with algebra. So if I did 5 times by itself 3 times, so 5 times 5 times 5. Now there's a way that we can simplify that. So 5 times 5 would be 5 squared. 5 times 5 times 5 is 5 cubed. Okay. We haven't started with 5, we've started with p. So instead of, it's going to be p times p times p, instead of 5 times 5 times 5, which simplifies to p cubed. Start with x, double it, and then subtract 3. Okay, let's start with 5 again. Start with 5, double it, so that means times it by 2, and then take away 3. So I'll take away 3 from whatever I get. So that's the number version. We're not starting with 5, we're starting with x. So let's change it to our algebra version. Start with x, double it, becomes 2 times x, and then take away 3. Now there's something slightly wrong with that, and it's just that we don't like the times symbol. And this is a really good example because we don't like x being so similar to the times symbol. So we ignore the times symbol and just put 2x, take away 3. Start with x, subtract 3, and then double it. Okay, let's have a look at what we would do if this was 5. Start with 5, subtract 3, and then I'd have to double it. But I need to find out this answer first before I double it. Okay, let's now work with x. So I started with x, I take away 3, and then I double it. That means I'm doubling everything inside that bracket. So x times 2 is 2x, and negative 3 times 2 is negative 6. We'll do more of this in a few videos' time. So it's 2x minus 6. Start with x, divide it by 3, and then add 5. So let's see what would happen if I started with 5 instead. Start with 5 divided by 3. Remember, a fraction is a division, so I can put it as a division. Divide it by 3 and then add 5 to that answer. So let's have a look at it with algebra. I start with x, I divide it by 3, and then I add 5 to my answer. Start with x, add 5, and then divide it by 3. So these are very similar questions, but it's all about the wording. So what would happen if I started with 5? Start with 5, add 5, and then divide by 3. So it's my answer there, divided by 3. But I didn't start with 5, I started with x. So let's pop that in. Start with x, add 5, and then divide by 3. So you can see the difference. So this one here is x divided by 3 and then add 5 to the answer. Here is x, add 5 and then divide by 3. So it's all of this divided by 3. That's the difference between those two. 7 pieces of identically sized pieces of timber are x centimetres long when put together. How long is each individual piece of timber? Okay. Let's just do a number example. I'm going to pick a number that's different to 5. I'm going to pick 10 now, because it doesn't matter what number we pick. So 7 pieces of identically sized pieces of timber. So I'm going to draw those in a bar. So there's one of them. There's 2. 3, 4, and 5, 6, 7. So there's my 7 pieces of timber. Now when they're put together, in my number example, they're 10 centimetres long. So if I want to figure out what goes into each one, how long each one is, I'd need to do 10 divided by 1, 2, 3, 4, 5, 6, 7. Divided by 7, or 10 over 7. We much prefer the fraction when we do algebra, so that's going to be important in a second. So that's my number. So what works? The number works with algebra. So I'm going to copy everything, except this time they don't add up to 10 centimetres, they add up to x centimetres. To find the length of one of those pieces of timber, I'd still have to do x divided by 1, 2, 3, 4, 5, 6, 7. So it's either x divided by 7 or x over 7, and that's the answer that we prefer.